Beneath the state of California runs a crack in the earth 800 miles long. Along its southern half, the ground has not slipped in a major earthquake since 1857, more than 150 years of silence, and in that silence, pressure has been building, day after day, year after year, beneath the feet of nearly 40 million people. Scientists have a name for what that pressure is quietly loading. They call it the Big One. This is the story of the San Andreas Fault. What it is, why the experts say it is overdue, and exactly what the United States Geological Survey believes will happen when it finally lets go. Start with the fault itself, because its scale is difficult to picture. The San Andreas is roughly 800 miles long, cutting through California from top to bottom. It is not a crack in the rock so much as a seam between two of the great tectonic plates that make up the surface of the planet. The Pacific Plate on one side and the North American Plate on the other. These two plates are not still. They are grinding past each other at a rate of about 1 to 2 inches every single year. It sounds slow, and it is. But it never stops. And over a century and a half, 1 to 2 inches a year adds up to something enormous. Here is the crucial part, and it is the reason the whole state watches this fault. The plates do not slide smoothly. Along most of the San Andreas, the two sides are locked together, snagged, held in place by friction while the deeper rock keeps moving. The strain builds and builds in the locked ground like a spring being wound tighter and tighter. And a locked fault has only one way to release all that stored energy. It snaps violently all at once. That snap is an earthquake. The longer a section stays locked, the more strain it stores, and the bigger the earthquake when it finally breaks. Now apply that to the southern San Andreas. The last time that southern section produced a major earthquake was in 1857 in an event known as the Fort Tejon earthquake, estimated at around magnitude 7.9. That was over 160 years ago. Since then, that stretch of fault, the stretch closest to Los Angeles and the millions of people around it, has stayed locked, winding tighter, and it has not released a major quake since. So how overdue is it? Geologists from the University of California, Irvine, and Arizona State University studied the fault's history and found that the largest earthquakes strike the San Andreas roughly every 45 to 144 years. The last one was more than 150 years ago. In other words, the southern San Andreas has now passed even the long end of its own average cycle. That is why the word that follows this fault everywhere is overdue. The reality is more complicated than a countdown clock. A fault does not owe anyone an earthquake on a schedule. But the pattern is real, and the strain is real, and it has been accumulating for over a century and a half. How do scientists know all of this about a fault that last broke before anyone alive today was born? They dig. Along the San Andreas, researchers cut deep trenches straight across the fault and read the layers of earth the way an arborist reads the rings of a tree, dating ancient earthquakes by the disturbed soil they left behind, and by the streams the fault has slowly shoved sideways over thousands of years. A creek bed that jogs abruptly where it crosses the fault is a written record of every great slip that ever moved it. That painstaking work is exactly how the recurrence interval, that 45 to 144 years, was measured in the first place. The overdue warning is not a hunch or a headline. It is dug, layer by layer, out of the ground itself. That brings the story to the numbers that actually matter, the ones the United States Geological Survey has put on the record. The USGS does not predict earthquakes on a date. What it does is calculate probabilities. And for the Los Angeles area, over the next 30 years, those probabilities are sobering. The agency estimates a 60% chance of a magnitude 6.7 earthquake, a 46% chance of a magnitude 7, and a 31% chance of a magnitude 7.5. Read those numbers again. This is not a fringe theory or a doomsday website. This is the official United States government science agency stating that a major damaging earthquake in the most populous region of California is closer to a coin flip than to a long shot. And when scientists wanted to understand what a truly large San Andreas earthquake would actually do, they did not guess. They built it. In 2008, a team led by the USGS seismologist Lucy Jones created something called the ShakeOut Scenario. It was a detailed scientific simulation of a single event, a magnitude 7.8 earthquake rupturing the southern San Andreas Fault. Not a movie, not a fantasy. A rigorous model built from real fault data, designed to tell California exactly what it would be facing. The results are the reason emergency planners across the state lose sleep. In the shakeout scenario, a magnitude 7.8 on the southern San Andreas kills roughly 2,000 people. It injures around 50,000, and it causes about $200 billion in economic damage, with billions more piled on top from the fires and landslides that a quake like this sets off. 2,000 dead, 50,000 injured, $200 billion. That is not the worst case a screenwriter could dream up. That is the measured scientific estimate of a realistic event on a fault that is already past its average. And those figures assume a degree of luck. A rupture in the middle of a working day, freeways packed, high-rises full, schools in session, could push every one of those numbers higher. To understand why those numbers are so high, look at what the San Andreas has done before. Because it has done this before, twice, in ways that still shape the state today. Go back to 1906. In the early morning of April 18th, the northern San Andreas ruptured near San Francisco in a magnitude 7.9 earthquake. The fault tore open along nearly 300 miles. The ground on either side shifted by an average of about 10 feet. In some places, fences and roads that crossed the fault were left offset by the length of a car. The shaking and the enormous fire that followed it destroyed much of San Francisco and killed more than 3,000 people. It remains one of the deadliest natural disasters in the history of the United States, and it is the clearest picture yet of what this exact fault is capable of. But the San Andreas is not the only threat, and this is the part that widens the danger. In 1989, the Loma Prieta earthquake, a magnitude 6.9, struck the San Francisco Bay Area during a World Series game, collapsing a double-deck freeway and a section of the Bay Bridge. Then, in 1994, the Northridge earthquake, a magnitude 6.7 on a hidden fault beneath Los Angeles, killed dozens and caused tens of billions of dollars in damage, from a quake far smaller than the big one that scientists are actually worried about. And running straight through the crowded cities of Oakland and Berkeley is another fault entirely, the Hayward Fault, which the USGS also rates as highly likely to produce a major earthquake in the coming decades. California is not waiting on one fault. It is sitting on a network of them. So what happens when the southern San Andreas finally releases? The science paints it in stages. First, the rupture itself, a tear racing along the fault at thousands of miles per hour, far faster than any warning can travel ahead of it in the region right on top of the break. That warning matters, and it is real. It is called Shake Alert, a system built by the USGS for the West Coast that detects the first, faster, less damaging seismic waves and races, an alert to phones and public systems before the slower, destructive waves arrive. For a city 100 miles from the rupture, that can mean tens of seconds of warning. Enough to stop a train, open a firehouse door, and take cover under a desk. But directly above the fault, where the shaking is at its most violent, the warning and the earthquake arrive almost together. The people closest to the big one will get the least notice of all. Then the shaking, lasting not seconds, but potentially a minute or more directly along the fault, long enough to bring down older buildings and buckle overpasses. Then the secondary disasters, which the ShakeOut scenario spelled out in detail. Broken gas lines, feeding fires, that firefighters cannot reach because the roads are cracked and the water mains are severed. Aqueducts that carry water hundreds of miles into Southern California, crossing the fault at the exact point where it moves, meaning a single quake could cut the water supply to millions of people for weeks or months. The big one is not just a burst of shaking. It is the moment a modern megacity discovers how many of its lifelines cross the same invisible line in the ground. And yet, and this matters, California is also one of the most prepared places on Earth for exactly this. The state has some of the strictest building codes in the world, an early warning system that can send an alert to phones seconds before the shaking arrives, and a public that has drilled for this scenario for decades, in part because of the shakeout work itself. The reason scientists publish numbers like 2,000 deaths is not to frighten people for its own sake. It is to make sure the number stays as low as it possibly can when the day comes. Across California, residents are urged to keep water, food, and supplies for at least several days, to bolt heavy furniture and water heaters to the walls, and to understand that in the first chaotic hours after a major quake, rescue crews may not be able to reach every neighborhood at once. Preparation does not stop the earthquake. It quietly decides how many people are still standing after it. Because on the science, that day is not a question of if, but of when. The plates are still moving, 1 to 2 inches a year, exactly as they have for millions of years. The southern San Andreas is still locked, still winding tighter, still past its average. No one, not the USGS, not any scientist alive, can say whether the big one arrives next year or in the next lifetime. What they can say, with the full weight of the evidence behind them, is that the strain from more than a century and a half of silence has not gone anywhere. It is still there, still building, still waiting under one of the most populated corners of America. For more disaster reports built on the real numbers and the real science, without the exaggeration, subscribe. And never miss the next one. Because somewhere along 800 miles of locked rock beneath California, the pressure keeps rising by the day. The fault has been quiet since 1857. And in the language of the San Andreas, quiet has never meant safe. It has only ever meant not yet.